Okay, so for my birthday this year, I decided that I wanted free stuff, not gifts. I wanted companies to give me free stuff, and I didn't want to pay for it. You see, I had learned somewhat recently that a surprising number of companies, mostly restaurants, will give you free things on your birthday. And it seemed like it would be fun to exploit. So I decided that for this birthday, I wanted to get as many free things in one day as I could. And I did. And it was great. That's not actually all of it. Those are just the times we remembered to take photos. But you know the saying, there's no such thing as a free lunch? Well, technically, I mean, that's exactly what I got, like many of those. But it was actually quite a lot of work. I live over here by New York City. But that's far too large of an area to cover, so really I had to narrow down to Manhattan. And can kind of cover Manhattan, but really it's too big unless you have a car, which you're not going to have in New York City. So really I had to narrow down to this little red square, Midtown Manhattan. So I had to scope down hundreds of retailers with thousands of physical locations. There's just these lists online, to dozens, maybe, in this little red box. And then I had to deal with the minutia of loyalty and rewards programs, and I will spare you the details, but they're a pain and really a surprising amount of work. And while I'm doing this, I'm thinking, this might be the dumbest thing I've ever done. I'm spending hours planning this, and the cumulative value of all this is, the far less than the time value of what I'm doing. But I keep telling myself that it's not dumb, because it's fun, right? And when I started doing this, I had recently begun working with this company called District 0x. District builds and distributes Ethereum apps using Clojure and ClojureScript mostly. Everything is open source on GitHub under the District 0x handle. So for District, I was working with them. I had just started doing Ethereum, and it was very challenging. Everything was probably 10 times harder than building the same thing in a centralized way. And I realized that I have the same feeling during work as I do after work when I'm planning my birthday freebies. Signing up for tons of loyalty programs to get free food is a pretty laborious way to eat, actually. And using Ethereum to create applications is a pretty laborious way to create applications. Now, to be clear, I'm not saying they're bad ways. I'm just saying that if you want frozen yogurt, perhaps stopping by the shop weeks earlier to pick up a physical loyalty card, which you might then bring to Helsinki to illustrate a point, so that their website would let you register so that weeks later, on your birthday, you can show up and get a frozen yogurt. It's perhaps not the best way, or not the most direct way to get a frozen yogurt. But it's the journey that mattered. And I can tell you that that frozen yogurt tasted better than any paid one. So I think that might be the case with Ethereum apps. They're definitely harder to build, but maybe, like my ridiculous birthday escapades, the journey and the possibilities are worth the effort. So I realized that this whole birthday thing would have been a lot easier if there was an application that allowed me to scope down places that give you free things for your birthday to just Midtown Manhattan instead of manually sifting through hundreds of promotions to find these locations. So today, we're going to build that. We're going to make an Ethereum and ClojureScript app, and it's going to allow users to curate a map of places where you can get free stuff for your birthday. We're going to use the same architecture as other District 0x apps use. So we're going to start with Ethereum. That's going to be our database, our distributed database. We will also have a ClojureScript web server. This is essentially going to be a sophisticated cache, which will allow us to do fast querying of the blockchain data by our ClojureScript client, which will request and receive data from the server with GraphQL. And then the client is not going to write to the server. It's going to write directly to the database, to Ethereum. So let's go through some background. So a blockchain is a globally shared transactional and immutable database. The basic idea is to allow untrusted parties to collaborate without risk via some fancy cryptography, math, and networking. Some blockchains can execute code. Applications built on blockchains are called distributed apps, or dApps. The Ethereum blockchain is probably the most well-known blockchain that can execute code. Programs written on Ethereum are called smart contracts, and they run within the EVM, which is a sandboxed runtime that Ethereum nodes run. Ethereum smart contracts have no access to the file system, internet, network, anything other than the blockchain and other contracts. So by using Ethereum as our database, we get a censorship-resistant, decentralized database with some of the benefits of Datomic, like immutability and easy horizontal scaling. Now, we could develop using the main Ethereum network to do development, but that is slow and it is literally expensive, not just computationally expensive, because you have to pay for execution. So instead of doing that, we're going to run a local private blockchain using a tool called Ganache. Ganache has both a UI and a CLI. You can kind of, like if you do AWS Lambda development, this is essentially like running a local Lambda server instead of paying for the real thing. So the EVM runs EVM bytecode, but obviously we don't want to code in bytecode. So that's where Solidity comes in. Solidity is the primary language that compiles to EVM bytecode. It's sort of like Java to the JVM, Solidity is to the EVM, probably more so in this case. Solidity and I guess the EVM are, in my opinion, not really even bleeding edge. They're kind of like cutting to the bone edge. Solidity looks kind of like JavaScript, which we'll see soon, but development with it is it's extremely challenging, at least initially. It kind of makes JavaScript seem fun in comparison, believe it or not. Quick story actually about how difficult this is. So when I started working with District 0x, I was getting up to speed, talking to different colleagues, asking questions, learning. And the topic of Solidity being challenging came up multiple separate times. And one of the older team members said it was like coding in the 70s, and he's probably been coding since the 90s. And then another team member, a younger one, at a different time, who's probably been coding since the 2000s, said that Solidity was like coding in the 90s. So I think if you want to understand how difficult Solidity is, just take the year you started coding, subtract 10 or 20 years, and like it's as difficult as whatever those unfortunate folks had to deal with before you started coding. So as an example, there's no logging, and by default, there's this one error message. This just means that in a transaction, there was an exception, and the transaction is reverting. That's all, and which is about as useful as this, because like if there's one error, there's like no errors, right? So hopefully I haven't scared you away too much. Let's write some Solidity. So this is going to be our contract. We're going to call it free lunch. We'll allow users to set locations that include data about those locations, so we need a storage place for that. So we're going to create a mapping called freebies. A mapping is an associative key value store. In this case, our keys are going to be strings, and our values will be bytes. We're also going to declare an event called freebie, which we will trigger later on in this contract, and that will allow listeners to be notified when we set or update a freebie. We're going to create a function, a public function, for setting freebies. So that's going to take a key, string, again, and value bytes. And then we're just going to set the value at that key in our mapping, our freebies mapping, to the value passed in. And then we're going to emit that event, again, so listeners know when something has changed. Now, we also need to read from the blockchain. So we're going to create a load freebie event. This is going to take a string, just the key, right? And again, it's public, but this is a view function, which essentially means it's pure. It's not changing any state. And you'll see here it returns both a string and bytes. So functions in Solidity that return things always return tuples. So if you return one thing, you're returning a tuple of one. In this case, we're returning a tuple of 2, the string key and the bytes value. And so all we're going to do in this function is return those two things. That's it. This is our entire smart contract for this project. And this is the only part of the whole thing that is going to run on the blockchain. Okay? Everything else is going to be ClojureScript. So to compile this, we need to use Sulk, the Solidity compiler. We have this lining in plugin for doing this called line Sulk. To deploy and interact with smart contracts, we're going to use Ethereum's JSON RPC API via its JavaScript wrapper, which is called Web3. District 0x has a ClojureScript wrapper for Web3, as well as 16 other libraries with Web3 in the name, or that directly depend on Web3. I think there might actually be more. I'm not really sure. Anyway, the point is, like, we use Web3 a lot, so let's use it. So on the server, which remember, just a fancy cache for our Ethereum database, we're going to define this function called load freebie. This is going to receive the freebie key, just like our Solidity function, and then it's going to get the freebie data from the blockchain by calling the load freebie Solidity function. We're going to use this district library for calling that contract. We'll pass in the contract name as kebab case, which will be automatically converted to camel case. Same thing with the function. And then we're just going to pass in the freebie key. Okay? So that's all. This is now a pure ClojureScript function calling a pure Ethereum function on the server. Now on the client, we're going to use reframe to call the set freebie function. So we're going to register an event with the same name. Doesn't have to be, but in this case it is. And that event is going to receive our freebie data, the ID, as well as the data hash, which is the bytes. We'll use another district library for sending a transaction to Ethereum. And into that library, we need to pass the instance of the contract, which we will pull from our app state database, the name of the function that we want to call in that contract, set freebie, and the arguments to that function, so ID and hash. Finally, we want to pass in transaction options. We did not have to specify this on the server because that was a read-only function. In this case, we are mutating. We are creating a transaction and changing the state on the blockchain. And to do that, we need to pay. So we have to specify gas, which is the maximum amount that we're willing to pay for the execution of this function. And we have to specify from, which is the account that is going to be doing the paying. So what will happen here is that the reframe event will trigger a pop-up that the user will be able to confirm or reject to send or cancel the transaction. This pop-up depends on a browser extension called Metamask. Most dApps require the use of Metamask or something similar. Essentially, Metamask allows users to sign transactions using their private key without leaving their browser. So as a user, you'll see a pop-up like this. It is essentially just going to say, what is the application trying to do? What is it requesting your permission to do? And how much will it cost? And then you can either grant permission by signing the transaction or deny by not signing it. Now, storing stuff on the blockchain is very expensive, and I again mean literally expensive operation compared to other operations. So we want to limit storage. So we're only going to store a hash of the actual data about the freebie on the blockchain. We're going to store the actual data in the interplanetary file system, IPFS. Although as far as I know, it is still only intraplanetary, but maybe they're working on that. So IPFS is a distributed file system. Each file is addressable by its hash and then split into chunks and distributed across nodes. It's sort of like a distributed BitTorrent. Thankfully, there's only 2 district IPFS libraries. So on the backend cache server, we're going to read from IPFS and read from Ethereum. And on the client, we're going to write to IPFS and write to Ethereum. Okay? So I said that the system looked like this, but I lied. It actually looks like this. So again, server reading from Ethereum, reading from IPFS, sending data to client over GraphQL, client writing to IPFS, writing to Ethereum. So on the server, to read from IPFS, we're going to create this function. It's just going to take the data hash, the bytes, and it's going to use this library to pull data from IPFS. I'm simplifying this a bit to remove JSON parsing and whatnot, but the gist is correct. And then this is going to return a promise. So on the front end, we want to write to IPFS. So we're going to create an add freebie event. This is going to call into IPFS using this other library, and it will call the add function, and then it's going to serialize our data as JSON and save it as just a JSON string in IPFS. And then when it's done, it's going to forward that on to the set freebie event that we did previously. So remember, set freebie receives the freebie ID in a map of data, and also the hash, the bytes. So that's what's going to happen here. The UI will trigger, after this, it will forward on to set freebie, and the UI will trigger that pop-up that we saw before. So we've talked about live reading from the blockchain being too slow, which is why we have that server cache. So we're going to cache using in-memory SQLite instance. And what we'll do is we will listen for freebie events, which we're triggering in our set freebie function. And then whenever we see one of those, we're going to write relevant data into our in-memory SQLite database so that we can quickly serve it to our clients over GraphQL. So we can scale this horizontally very easily, right? Because this is just an in-memory SQLite database. So to do this, we're going to have to first define a event handler. We're going to call this onFreebie, and we're going to end up calling this every time that we see a freebie event. So in this function, we'll get an event. We will pull the freebie ID, that unique string, out of that event. And then we'll take that string and we'll call our ClojureScript load freebie function, which will call through to Solidity load freebie, which will return us a map of the freebie data. And then out of that map, we're just going to pull our data hash, our bytes, and then we're going to take those bytes and we're going to get the IPFS data that we stored about that freebie event. And then once we have that data, which is going to be a promise, once it resolves, we will either insert that or replace that in our database. Now we need to listen for those events. So the way we're going to do that is with the same library, we're just going to call the contract, again, kebab case. This time, though, instead of having a function name here, we have the event name, right? So we're saying we care about the freebie event. And we don't just care about it going forward. We care about it from block 0, from the beginning of time. So this is going to go through the entire blockchain, and every time this has been seen, it will trigger this event and save it into our database so that we can recreate the proper state. And then every time that we see that event, we are just going to call onFreebie, okay? And that's essentially it. The only additional thing is using GraphQL to send data from the server to the client. District has a few GraphQL ClojureScript libraries. We don't really have time to talk about GraphQL today, but the TLDR is that it is an alternative to REST, which I think is superior in most use cases. If you are curious, I did give a talk at ClojureD earlier this year about GraphQL, in which I compared it to Japanese toilets, so feel free to watch that. Anyway, so we now have an app. The full free launch app is available on my GitHub account here, and maybe you can use it. Maybe you will plan your own free birthday extravaganza if you so choose, and I would urge you to. Not only will you get a free lunch, or 10 maybe, but taking the long path can be fulfilling. I had some interesting experiences. I actually ended up in Hooters for the first time in my life, and it was about as awkward as you would imagine. I found a balcony which looks like it's from Harry Potter. And elsewhere in the city, I stumbled upon this beautiful church. I mean, the photo doesn't do it justice. It's breathtaking. But right nearby this church, I found the Venezuelan consulate, which looks about as good as you would expect the Venezuelan consulate to look these days. And near that, I found a Nintendo store. I didn't even know these existed. It was awesome. I guess my point is, the outcome was achieved, right? I got the free stuff. But the journey and the side effects were also meaningful. And I think that is the case with dApps, where very early, and development is very challenging, but that doesn't mean that it cannot be worthwhile. So you may have noticed, this has been a talk almost entirely about how to build a dApp, not why to build a dApp. I find it a little interesting how quickly we often turn to this question, and I'm consciously choosing to avoid that, primarily because we don't have time, but partially because I don't think it is a necessary question. If you talk about making music with Clojure or writing poems with Clojure, no one asks why. But if you talk about cryptocurrency, it's suddenly existential question time. Most people seem to be either incredibly enthusiastic about it or incredibly pessimistic about it. There's an unhealthy amount of hype about cryptocurrency, and that leads to an unhealthy amount of cynicism. So dApps don't have to be the answer to everything. And dApps don't have to be the answer to everything, and they most certainly are not the answer to everything, despite what some promoters might say. But that also doesn't mean that they have to be the answer to nothing. They enable building a type of application that was previously impossible. And maybe that type of application may turn out to be applicable to an extremely narrow set of problems. But again, that type of application was not previously possible, and therefore, it's worthy of exploration. So dApps can be something without being everything. So keep an open mind, but not so open that your brain falls out. And please, have fun.
Thanks, Dom. I think we could do 1 or 2 questions if you have quick ones.
There's one not so kind of nifty and bleeding edge question I'd like to ask. If the server was written in ClojureScript, what did you use for just making a GraphQL server with ClojureScript?
There are well, I'm not remembering the word, which is why I don't like live questions. But the primary GraphQL implementation is in JavaScript that runs on Node. So
So you were using that directly like that?
Well, I mean that's what those GraphQL libraries that I showed on screen are. Some of those are doing. It's wrappers for the Node library.
Okay.
But there are wrappers not wrappers. There are GraphQL libraries in essentially every language at this point, including Licinia, which is a pretty high performance Clojure one from Walmart.